Very warm welcome to all of you in these classes. And in today's class, we'll be doing functional group 2. As far functional group 2 is concerned, it basically consists of aldehydes. So we'll be studying about aldehydes, ketones, carboxylic acids, and their derivatives. So this is what we are going to do in today's class. And in today's class, actually, when we talk about a function group, like when I talk about aldehyde and ketone, I taught you one thing earlier that we first do their method of preparation. After that, we do their physical or chemical properties. And in a short span of time from now, I'll be adding some exercise questions also to the playlist. Means you'll get some playlist of the chapters, and after the end of the chapter, you'll be getting some questions which I'll solve for you, and those will be the important question from those chapters. This is what I'm gonna do. Students, as far these classes are concerned, your feedbacks are really very valuable because they help me to improve these lectures, and these lectures, believe me, they are only for you. That's why I'm putting them on YouTube. I'm not charging anything for that. I'm just putting them for your help. So in case you come across any shortcoming in these videos, you want any sort of improvement from today's class, I am sharing my contact number with you. You can share your suggestions by sending a message to me. So definitely I'll keep each and everyone's view in mind, and I'll be improving these classes for you. In today's class, we'll be talking about aldehyde and ketone. We'll see their method of preparation. As far aldehyde and ketone are concerned, first let us see their basic structure. All functional group 2 compounds are carbon monoxide derivatives. That is, they have carbonyl group. If I talk about aldehyde and ketone, they have at least one hydrogen atom attached to carbonyl group. The other one can be an alkyl group, or it can be a hydrogen also. Whereas in case of ketones, both the group which are attached to carbonyl group are alkyl group. They can be same or they can be different. Before starting with their method of preparation, I would like to just share a basic oxidation product of alkanes, which you have done in your 11th standard. Like if you oxidize an alkane always on oxidation gives you an alcohol. Alcohol on oxidation gives you aldehyde or ketone, which on further oxidation will give you carboxylic acids. For this, I would like to give you an example. Suppose I have methane. I am oxidizing it. Oxidation means what? It is simply the addition of oxygen or removal of hydrogen. Addition of oxygen or removal of hydrogen is what oxidation is. So here in this case, I will get CH3OH because oxygen is getting added. Likewise, on further oxidation, two hydrogen, they will come out as H2O. I will get a compound that is HCHO, which is formaldehyde. So now I'm getting an aldehyde. On further oxidation, it will give me formic acid. So this is what I'll get. And this is the basic rule, means this is the basic sequence which they follow. Alkanes on oxidation gives you alcohol, alcohols on oxidation gives you aldehyde or ketone, and aldehyde or ketone on further oxidation gives you carboxylic acid. Now if I want to prepare aldehyde and ketone, what I can do, I can prepare them either by the oxidation of alcohols or by the reduction of carboxylic acids. This is what we can do. So first method which I am going to tell you is from alcohols. From alcohols will do. How from alcohols? The simple thing is by oxidation, as I've already shown you. The oxidizing agent we can use is alkaline KMnO4. Alkaline KMNO4 is a good oxidizing agent. It is one of a strong oxidizing agent. In alkaline medium, KMNO4 behaves as a strong oxidizing agent. Well, in this case, we have to remember one thing, that primary alcohols on oxidation will give us aldehydes. So from primary alcohols we'll get aldehyde. Now suppose here I have a compound like CH3, CH2OH. It is undergoing oxidation by KMNO4. KMNO4, as I told you, that oxidation is simply either addition of oxygen or removal of hydrogen. So from this compound it will take out two hydrogen that will combine with oxygen and will come out as H2O. I will get compound CH3CHO, that is ethanol. Ethanol or acetaldehyde. Similarly, if I have got a 2-degree alcohol, 2-degree alcohol on oxidation will give me a ketone. We'll see how it happens. Now suppose I have got a compound CH3, CHOH, CH3. This on oxidation will remove two hydrogens from the compound and they'll come out as H2O. I will get compound CH3, CO, CH3, that is acetone or propanone. Acetone or propanone. So this is what we can do. But the problem in this oxidation is KMNO4 is a good oxidizing agent. It's a strong oxidizing agent. It will not only oxidize alcohols to aldehyde and ketone, but will further oxidize them to carboxylic acids. Now, if we want the reaction to stop at aldehyde and ketone and not to proceed to carboxylic acid, we need to use a weak oxidizing agent, not KMNO4, but a weak oxidizing agent. So instead of KMNO4, we can use a weak oxidizing agent like Collins reagent. So by Collins reagent. Well, what's Collins reagent? Its other name is pyridinium chlorochromate. Pyridinium chlorochromate. It consists of pyridine, that is C5H5N dot HCl dot Cr2O3. So it will have pyridine. When it will react with HCl, it will form pyridinium chloride. So pyridinium chlorochromate means chromic oxide you have got. That is actually the oxidizing agent, a weak oxidizing agent. So if you oxidize alcohol by PCC or pyridinium chlorochromate, same reaction will occur. That is, primary alcohol, as you can see here, primary alcohol will give you aldehyde and secondary alcohol will give you ketone. Same reaction will occur. The only thing is the reaction will not further proceed to carboxylic acid. So the oxidation will stop only at aldehyde and ketone. So this is what we can do, oxidation by KMNO4 or oxidation by PCC. Now the next method we'll see. The next method is from alkenes or alkynes. Well, as far these methods are concerned, you have done these methods in 11th standard. Whenever a reaction comes which you have already done in 11th standard, my only objective of reminding this thing is that it was there in 11th standard. If you want to recall it, you can recall it from there. But no doubt I'm going to teach you that reaction. I'll not leave that. Since it was in 11th standard, I'm not going to teach you. It's not like that. See, from alkenes, now if I talk about alkenes, the reaction which we did in the 11th standard was ozonolysis. ozonolysis. We'll see how this reaction proceeds. Now suppose I have got a compound like CH2 double bond CH2, and I'm reacting it with ozone. Remember one thing, ozone always gets added to the double bond, so it will get added to the double bond. I'll get a compound like this, that is CH2 CH2. Here you can see that ozone has got added. Such a cyclic compound is known as ozonoid. If I react this ozonoid with zinc and water, this reductive ozonolysis, this zinc will combine with this oxygen and will come out as ZNO. As soon the zinc will combine with oxygen and will come out as ZNO, this whole structure will undergo lysis. It will break. How it is going to break? This part will come out where you'll have HC double bond OH, and this part again will come out. So you will get 2 moles of HCHO. So aldehyde is what you are getting. If you want to prepare a ketone by this method, the only thing which you have to keep in mind is that the carbon which is forming multiple bonds should not have any hydrogen with it. I give you one example for that also. Now suppose I got a compound CH3 CH double bond CH3 CH3. Here you will see 2 carbon atoms involved in double bond. One of them has got hydrogen, so that will form aldehyde. The other one does not have any hydrogen, that will form ketone. So on reaction with ozone, they'll form a ozonoid, and their ozonoid will appear like this, where here you are having CH3H. This carbon will not have any hydrogen. You'll have it like this. This is the ozonoid you are getting. On reaction with zinc and water, this oxygen will come out as zinc oxide. This part of the compound will break. This part of compound will break. So one of the compound which I'll get will be formaldehyde, that is HCHO. And the other compound I will get is CH3COCH3. So one of the compound I am getting, well, here I would like to make a rectification, because here we have got a methyl group. So this is not H actually, this is CH3. So here in this case, you can see that one of the compound is acetaldehyde, where the other one is acetone. So one is an aldehyde and the other one is ketone. Well, this reaction is not only used in preparing aldehyde and ketone from alkene, but it is also used to determine the position of double bond in the compound. Suppose I have been given a compound like C4H8. If I have a look at this formula basically fits into the formula of alkene, that is CnH2n. But the 2 possible alkenes can be CH2 double bond CH, CH2, CH3. And the other possible alkene is CH3, CH double bond CH, CH3. Now the question comes to our mind where the double bond is, whether it is but1-ene or but2-ene. Ozonolysis can tell us. If I carry out ozonolysis of this compound, and the product I get will be a formaldehyde, that is HCHO, and a propanaldehyde, because it is going to break from this double bond. So the other compound I will get is CH3, CH2, CHO. On the other hand, if I carry out ozonolysis of this compound, it will break from this double bond, and on either side of the double bond you have got same number of carbon atom. So you'll get the same compound, that is you'll get 2 moles of CH3 CHO. So if in a question, if a question is given like there's a compound with a molecular formula C4H8, and on ozonolysis it gives a molecule of formaldehyde and a molecule of propanaldehyde, that automatically means it's butyl. And if it is given like there's a compound with a molecular formula C4H8, and on ozone lysis it gives us 2 molecules of acetaldehyde, that means it is butene. So ozone lysis, this method is not only used in the preparation of aldehyde and ketone, but it is also used in determining the position of the double bond. So this is how we can prepare aldehyde and ketone from alkene. Next I'll show you from alkynes. So next will be the B part, that is from alkynes. If we talk about alkynes, in that I'll carry out the hydrolysis of alkynes. That is, in that I'm going to react it with H2SO4 along with HgSO4. And this H2SO4 in this case is dilute, so water will get added. Now suppose I have got an alkyne like CH3, C triple bond CH. Dilute means water molecule will get added, so water will get added. Many times instead of H2SO4 and HgSO4, you will find it written like H positive in the presence of Hg2 positive. That again means the same thing, that is H2SO4 and HgSO4. In the presence of H positive, water molecule will break up into 2 parts, that is H positive and OH negative. Now in the presence of water, pi electron will move toward one of the carbon atom, that will become negative, the other carbon will become positive. This electromeric effect. And you know, since 2-degree carbocation is more stable, so only 2-degree carbon is going to, or more highly substituted carbon is going to acquire the positive charge, and the less highly substituted carbon is going to acquire the negative charge. That means the H positive from water will attack on CH and the OH negative will attack on carbon. That means I'll get a compound like CH3, COH, double bond, CH2. If you say this compound is enol, that is propene to all, you'll see that OH group is at second position and it's a derivative of propene. So it is enol. All compounds which are enol, they undergo tautomerism to keto form. So this will also undergo tautomerism. It will tautomerize. In tautomerism, what basically happens, the hydrogen atom will shift its position. So this hydrogen atom is going to shift its position. And in tautomerism, the hydrogen atom shifts its position from one polyvalent atom to third polyvalent atom. So from here we can see 1, 2 and 3. So H positive is going to come here. Why H positive will come here? Because again, this pi electron will come here. So this carbon will acquire negative and this carbon will acquire a positive charge. Well, when H positive is moving, that means oxygen is acquiring a negative charge. So oxygen and carbon form a multiple bond. That means the compound I will get is CH3, C double bond O, CH3. So ketone is what I am getting in this case, that is acetone. So by hydrolysis of alkynes, we can get aldehyde and ketone. Had it been ethine or acetylene, I would have got acetaldehyde. So it basically depends. So this is all about the method of preparation from alkenes and alkynes. I told you preparation from alkenes and alkynes. So this we have done. So by now we have done 2 methods of preparation. First is from by oxidation of alcohol. Second is from alkenes and alkynes. Now the third one we are going to do is from cyanides. The third we'll see from alkyl cyanides. How to prepare from alkyl cyanides? Well, in that case, first we'll carry out reduction. So by reduction followed by hydrolysis. So this is what we can do. Reduction followed by hydrolysis. Suppose I got a compound like CH3CN and I am adding two nascent hydrogens. Where from these nascent hydrogens they are coming? They are coming by the reaction of tin with HCl. When tin will react with HCl, that will form SnCl2 and will release two nascent hydrogens. These nascent hydrogen will react with the cyanide and will reduce it to this compound. This compound is imine. Imines, see, after this we'll do hydrolysis. So if I carry out its hydrolysis, that is H2O in the presence of H positive by adding dilute acid, H2O will break up into two parts, that is H positive and OH negative. Well, in this case, we'll have two water molecules in fact. You can see that two water molecules means four hydrogen and two oxygen. So one of the oxygen will combine with CH3CH. That will form CH3CHO acetaldehyde. Three hydrogens they will combine with NH. They will come out as NH3. Or we can say we'll simply take one water molecule in this case, because it is getting balanced by one water molecule. So simply add a means dilute acid. So one water molecule that is going to react. And as I have told you, one water molecule means, see how I'll make it more clear to you how it actually happens. Initially, water will break up into H positive and OH negative. As I told you, this OH negative will further break into O2 negative and another H positive. So from a water molecule, we are getting two H positive that will combine with NH and will form NH3. So they will come out as NH3. We are left with O2 negative that will combine with carbon and will lead to the formation of CH3CHO. So acetaldehyde is what we are getting. So this is how the reaction is occurring. And this reduction process is known as Stephen's reduction. My dear students, you have to remember one thing, that this is the only reduction process where the reduction is followed by hydrolysis. Same reaction we can do with diol also. Diol H, that is diisobutyl aluminum hydride. This again is a good reducing agent and it selectively reduces the CN part to imine. Now suppose I have got a compound like CH3CH double bond CH CH2CN and I reacted with diol H. Diol H will not reduce the multiple bond, it will reduce only the cyanide part. So you will get a compound that is CH3 CH double bond CH CH2 imine. This compound is then followed by hydrolysis by dilute acid, as I told you earlier. So this will give a CH3 CH double bond CH CH2 CHO plus NH3. So you can see that diol selectively reduces the cyanide group. It does not reduces the multiple bond. So multiple bond will not undergo reduction by this. Had it been some other reducing agent like hydrogen in the presence of nickel or platinum or cobalt, mercury, then the double bond would also have undergone reduction. But now in this case, only the cyanide part will undergo reduction. Diol is not only used in the reduction of cyanides, but it is also used in the reduction of esters to aldehyde and ketone. Suppose I got a compound like CH3, CH2, CO, OCH3. Methyl propanoate is what I got. And if I react it with diable H, it will break the bond from here and will reduce it. I will get CH3, CH2, CHO, and along with that I will get CH3OH. So this is how it carries out the reduction. So from cyanide I can get aldehyde by Stefan's reduction followed by hydrolysis, or by reduction with diable. Remember one thing, that you will get only aldehyde by this method, not ketone. From cyanide, I can also use another method, that is by a reaction with Grignard's reagent. By reaction with Grignard's reagent. Now, if I got a compound, a cyanide, that is CH3, C triple bond N, and I am reacting it with say CH3 Mg Br, then the bond between Mg and Br will break into Mg positive and carbon negative, because metals, they have a tendency of donating electrons. Pi electron will come toward nitrogen, because nitrogen is more electronegative, that will become negative and carbon will acquire a positive charge. So CH3 will attack on the carbocation and Mg positive will attack on the nitrogen. This reaction will occur in the presence of dry ether. I will get an additional compound like CH3, C, CH3, double bond N, Mg, Br. Well, all the reactions of Grignard's reagent are followed by hydrolysis. So in this case also, it is followed by hydrolysis. H2O in the presence of H positive. Dilute acid is what I am using. From here, actually two water molecules, they are reacting in this case. So I will get a compound like CH3, C, CH3, double bond O, plus NH3, plus Mg, OH, Br. Magnesium hydroxy bromide is moving out. So this is how this reaction occurs. Initially, the Grignard's reagent will undergo addition reaction. It will, on undergoing addition reaction, it will form an additional complex or adduct. That adduct will undergo hydrolysis, because the reaction of Grignard's reagent, they are followed by hydrolysis, and will lead to the formation of a ketone, that is acetone, or propanone. So this is how you can prepare aldehyde and ketone from cyanides. Next we'll see from carboxylic acids, but I'll make this lecture short. See, I'll not give you a lot, means more quantity of reactions. I'll give you only that much reactions which you can revise. So in today's class, I'll give you only these reactions. That is method of preparation of aldehyde and ketone by oxidation of alcohols, oxidation by KMnO4 and PCC, that is Collin's reagent. After that, from alkene and alkyne mediate, I'll show you. From alkene and alkyne mediate, alkenes, that is ozonolysis. Utility of ozonolysis, that is not only used for converting alkenes into aldehyde and ketone, but also to locate the position of double bond. Then alkynes, after that from cyanide. In cyanide we did reduction followed by hydrolysis, by Stefan's reduction and by diable. Esters, reaction of cyanide with Grignard's reagent. This is what we did. I'll keep it short. In today's class, I'll teach you only this. In next class, we'll be doing the method of preparation from carboxylic acid and their derivatives and aromatic. This is what we'll schedule for the next class. My dear students, please do revise these reactions because organic, as far knowledge of organic chemistry is concerned, that is very volatile. If you not revise this reaction, you will forget them. And or you can do one thing, whenever you get time, kindly do watch these videos. Because the more the videos you will be watching, the more the revision you are doing, and it will become clearer time and again. Again, I would like to add one more thing, that I am sharing my contact number with you here. Any suggestion, any problem, any question which comes to your mind, simply send me a message. I'll revert back. Please do send that message on WhatsApp, because many times it happens that I'm not in a network area, but Wi-Fi is they are working. I'll get that message and I'll revert back. And please don't forget to subscribe my channel and press the bell icon for getting all the notifications. So this is what we scheduled for today. In the next lecture, you will be getting more method of preparation of aldehyde and ketones. Thank you very much. Thanks.